Hi everybody, this is our second video on compound probability. In the last video we talked about mutually exclusive and overlapping events, and we talked about when we saw the word or, that would mean addition. So this time just a note that when you see the word and, that's going to mean multiplication. So some vocabulary here, we've got independent events. These events are not affected by previous events. For example, we put something back, there's a replacement. We'll talk about that in a bit. And dependent events, they are affected by previous events. For example, we don't put something back, and we'll explain that a little bit more here in the examples. So the first one, it says a box contains 3 blue pens and 5 red pens. You choose one pen at random, but do not put it back. Then you choose a second pen at random. What's the probability that both pens are blue? All right, so we've got 3 blue pens, 5 red ones. We've got 8 pens total. So what this example is telling us is that we're going to choose a pen first, and then we're going to choose another one. And it wants to know what's the probability that both pens are blue. Okay, well, looking at the first choice here, if I was going to pick a pen, and I'm wondering the probability that it's blue, well, there's 3 blue ones out of 8. So we have a 3 out of 8 chance. However, for the next one, it's also saying what's the probability that both pens are blue, but another key piece here is that we do not put it back. So basically what just happened over here was I went in to pick a pen at random, wanting it to be blue. So when I take that pen out, I have now moved that pen. I took it out, and it's no longer in this as a choice. So technically, I now have one less pen to choose from, right? So now how many blue pens are there? Well, now there's only 2 out of 7 pens to choose from, okay? And we multiply them together because we are wondering, we're looking at the word and. So 3 times 2 is 6, and 8 times 7 is 56. We could also simplify that if we wanted to be 3 out of 28. All right, so that's the first example. Let's look at the next one. So here it says we have a bag with 4 green marbles, 2 red marbles, and 1 blue marble. Okay, so we've got the 4 green, 2 red, and 1 blue. So this says, what is the probability of selecting a blue marble and then a green marble? You put the blue marble back before picking the green marble. Okay, so this time we're going to pick a marble, but then we're going to put it back. So the amount of marbles in the bag doesn't change. So our first selection, we are wondering what's the probability of selecting a blue marble? Okay, so when I look here, well, how many marbles are there total? 4, 5, 6, 7. So there's 7 marbles total. And there's 1 blue, so that'd be 1 out of 7. Now our second choice here, I'm going to get rid of these lines. And then our second one says the probability of getting a green marble. All right, well, I see that there's 4 green marbles, and that would still be out of 7 because we took a marble for our first choice, but then we put it back. So that would be 4 out of 49. Okay, but part B, okay, so now part B is very similar. It says, what's the probability of selecting a blue marble and then a green marble, but you do not put the blue marble back before picking the green marble. Okay, so that's really important here. So same idea. What's the probability of getting a blue one? Well, we've got 1 blue one out of 7 marbles. But this time, when we went to pick the marble out of the bag, we did not put it back. So now it's not in the bag anymore, okay? So the probability we get a green marble would be 4, but now there's only 6 marbles left in the bag. So that would be 4 out of 42, or we could simplify that to be 2 out of 21. All right. So let's look at number 8. This one's a little different. We're looking at cards. It says you have a stack of cards numbered 1 through 20. Okay. You randomly draw 2 cards from the stack, one at a time. Find the probability that both are even if. So let's look at part A. You put the first card back. Okay, so it wants to know the probability that both numbers are even. So, well, how many are even here? We've got 1 through 20, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 even numbers out of 20. So the first time we pick a card, we've got 10 out of 20 that are even, times, so we put the first card back, so there's always going to be 20 cards to choose from, so 10 out of 20. Okay, so that would be 100 over 400 when we multiply them. We could also simplify that to be a 1 out of 4 chance. Okay, now the next one we do not put the card back, the first card back. So the probability that it's even the first time is still 10 out of 20, but now we have one less card. So let's say, now that one's, that one's gone now. So we only have 19 cards to choose from, and assuming that the first one was even, we only have 9 evens. And that would be 90 out of 380. And we could simplify that to be 9 out of 38. All right, so that's the end of our compound probability video for today. The next video, we're going to be talking about Venn diagrams. Thank you for watching.